Hi everyone, this is Anurag, one of the co-founders at True Foundry, and today we have with us Mon. True Foundry, we have been building for the last 2 years with the aim of making it easy for companies to train and deploy ML as well as LLM models in prod and do it at a very low cost as compared to the other competitors, as well as with the best SRE practices. So we have Mon with us from GitLab. As everyone knows, like GitLab is a AI-powered DevSecOps platform, one of the biggest ones, listed company, more than $6 billion, and has raised more than $400 million in itself. Mon leads the AI research vertical at GitLab today, with a lot of focus on the LLMs over the last 1 year. And prior to that, she was an engineering manager in the ModelOps division at GitLab. She also kind of worked with other companies like Microsoft, eBay, and would love to kind of have her here to talk about the experience. So, Mon, pleasure to have you here. Love for you to kind of maybe give a detailed intro and take it from there.
So my full name is actually Monmayuri, and but people call me Mon. I'm based out of Sydney, Australia. I have been in GitLab for 3.5 years. And yeah, when GitLab started their journey in building ML teams, we started as a group ModelOps, which had two verticals or categories of applied ML and MLOps. And then with Gen AI, it's all expanded to a lot more verticals as part of a new stage called AI Powered. And now I lead the model validation and research team, which does currently focus on Gen AI as part of enabling Gen AI evaluations, infrastructure, all of that for all the other various teams. Yeah, thank you for
Awesome.
having me.
Thanks a lot, Mon. And I'd love to kind of maybe if you can share 2 minutes about what are some of the use cases of ML internally within GitLab that GitLab sees for benefiting its users. So maybe we can start there.
Yeah, so currently with my team, one of the use cases is really being able to evaluate Gen AI models catered to specific product cases. So whether it's for a text completion, chat, explanation, what is that right model for the right sort of use case, what kind of prompt transformation would really help, how does that architecture look like, so you can actually have a good balance of quality, cost, latency as throughout the throughput of that. So yeah, so that's sort of what keeps us sort of busy these days, and it is obviously an area which is very experimental and it is moving quite rapidly.
Awesome. Maybe you can talk a little bit about the benefit that this will offer to, say, the customers of GitLab in terms of the end user benefit of the products that you are working on, say from a code completion perspective and other perspectives. If you can highlight that, that will be really good for the users.
Yeah, so for our the end user parts of art are all about empowering AI throughout your developer journey, from really about creating an issue to merge requests to deploying an app, and where does AI actually fit into that. So code completion is just one of the use cases where a developer would have an AI assistant to predict the next code. There are lots of things like issue summarization, where you just write a lot in an issue and you want AI to summarize it for you. You almost want a chat, which is sort of a human coder assistant that can also support you through it. So the use cases are end to end. We work very closely with obviously the product teams, and to really align with the AI strategy as to what those use cases will entail. As there are more LLMs, and then there are more various creative ways of solving maybe even traditional problems, but with a new lens.
Understood. Great. So, would love to deep dive a little bit into, like, as the LLM use cases have started to come in over the last year. and prior to that, like, there was still a lot of work going on the modeling side. So how has the infrastructure internally at GitLab evolved? So maybe you can take us through the earlier ML infrastructure that enabled the pipeline from training to deployment, and then what is changing in that today. So it'll be great to cover that.
Yeah, so in one of the first ML feature that came out of GitLab was called suggested review, where you suggest a review for your code based on your style of code, your MR history, availabilities, people who love code reviews, and to recommend the right reviewer for your code. That went through what would be called the traditional ML sort of pipeline right before the boom of Gen AI. The as far from a GitLab side of perspective, it's fascinating because GitLab has been written in ROR, Ruby on Rails, Vue.js, and Java. So whatever your Python ML engine is, you got to somehow figure a way to wrap it with this beast of a big engine. So so that, and then every feature is in different parts of GitLab, right? So this is sort of in that sidebar panel. So it comes with its own sort of I guess challenges and also sort of fun little parts, which goes even beyond just a traditional ML pipeline for, I don't know, something internal of doing a churn report or things like that. So so as far as us building that, we definitely used we were heavily reliant on Google Cloud and a lot of the stack that comes out of it. So a lot of the pipelines were Google Data Flow, but that's integrated to GitLab CI/CD for the CI/CD for machine learning, using the GitLab container registry. Flex to be our model registry, and then using and then deploying it via Kubernetes into integrated to the backend and front end of GitLab in the ROR endpoints and Vue.js as we go. So kind of a combination, I want to say, of Google Stack, GitLab for its flexibility to be really extending from DevOps platform to actually being able to use it as an MLOps platform too, and then being able to wrap it with the front end. It has been in the past. It has been a lot to do with Git-based machine learning. So everything was nicely version controlled and stored into in a fashion which was those days a little bit probably different to traditional ML teams as well.
Okay,
Uh,
understood.
uh, yeah.
And when you say the Google stack, you mean like something like a Vertex? You mean like?
Yeah, so this is even before. So this is to do with like Google Data Flow. So for the
Okay.
the data ops part of it was predominantly Google, and then it was deployed in Google Cloud. So there's a deployment and data part. So the data ops was very much Google, then goes into MLOps was very GitLab, the CI/CD part of it.
Okay.
And then we very much used Google to deploy with every version of the model as well. Yeah.
And where did you all run your training or do your experimentations? Was that kind of also in the Google Cloud? Like, say
Yeah.
for example, you have to spin up like an infrastructure to run a training job, like for example.
Yeah. Very much. So it was we most of it, the training was done in Google Cloud, where we would create our own environment for training, for testing, and then deploying.
Okay, understood.
Yeah.
Cool. And now coming from there to current, right? Like where it has a lot of LLMs being used. Like, first question, like, do you all kind of build your own LLM, or are you using one of these open source LLMs out there, and then trying to kind of evolve it for say the code generation and other use cases that you talked about? So maybe deeper dive into that a little bit.
Yeah. So yeah, so we've also had an interesting journey. We started with actually taking a open source LLM. So this is last year, where the landscape has also changed a lot from last year to now, but this was on the early days where Salesforce Code Gen had sort of released. And so we started taking that and really experimenting with it, of how much we can actually stretch to that. So most of the pipelines to sort of do with it were almost similar to what we had for our first feature suggested reviewer. Minus the fact these are LLMs, so there is a whole dance of GPUs that actually comes into it, and there is a backend for the models, including Triton inference, fast transformers, and they have their own sort of setup and challenges that come. So that was a massive shift to really being able to the model size are bigger, they take longer to tune. And so what is that right balance of setting up the GPUs, load balancing, and then how do you actually set up the Triton inference setup as well, as we go as part of it. So that probably was, from an infrastructure part, a massive shift. Especially during fine-tuning times, and knowing what layers, how long, how many GPUs, how much do you take. And then the other part was figuring out the balance for inference, because these are pretty high volume queries, and what is the good right balance of cost and latency that you want to do to actually optimize. So how many clusters, how many GPUs per clusters, what kind of dynamic batching, what kind of inference serving, even little things that model warm up, quantization of models. These were like the kind of things that a newer set of problems because of the size that comes in. Yeah.
No, that makes sense. That's something we have been seeing in a lot of our clients using LLMs. So maybe we'll deep dive into this journey of LLMs, because that is something a lot of people are excited about, and some of the similar problems that you have probably solved that people are looking to solve. So I'd love to start with when how has the training infrastructure for LLMs changed, right? Like say for example, when you have to take an existing LLM like a Salesforce Code Gen you mentioned, and then you have to fine tune on your huge data sets, like how do you even go about estimating the amount of GPUs resources that will be needed, and what sort of batching you'll need to do to be able to run the fine tuning in a faster speed. So would love to kind of dive into that a little bit.
Yeah, I think from a estimation point of view, it has been basically even starting small. So really just having a very, very small batch size. And it could literally be a finite number of lines, and seeing on an hourly level of training what it looks like. So for a very small sample, to get a better sense, and then being able to just scale it up for a larger sample and figure out. So if you're using like a NVIDIA high GPU versus when should you shift it to an ultra GPU, or when should you shift it to a TPU, those are the kind of really just being able to start very small, get a very good understanding of your hourly resource, and then kind of map it up into then shifting it. The other thing that is also sort of is another sort of a strategy is really being able to have a way of if it depends on areas where if you have multiple resources of different kinds of GPUs, is really being able to ensemble it. Like when your traffic is very, very low, you don't really need the high ultra GPU and then drop it to a lower GPU. So really being able to figure out the smart ensemblings of GPUs at the right time, at the right traffic. This is maybe not a training, but more on the inference time. it's really important to really actually balance that out. But as far as training, it was a very simple of really taking an hourly rate and just scaling it out, and getting a better sense.
Okay, understood. And how do you kind of, when you're kind of doing this training, and one of the things that happens with these large language models tends to be like there are so many different parameters. It's not like 10, it's like thousands of parameters. So how do you even go about choosing which are the right parameters to optimize for, and where you should focus on, so that the fine tuning can be more optimal and can be more faster? So any nuances that you have seen around that?
Most of it is honestly, for us, was a lot of experimentation. This is something of a learning curve where it would really depend on the type of model, the size, the kind of training data that is there, the kind of all of everything put together. And it is a little bit of a experimental process where one needs to actually experiment it. The olden days, you're spending a lot of time experimenting, actually feature engineering in the data. In the this day, it's a lot of actually experimentation with your infrastructure to support these. So
Right.
this is a little bit of a trial. It's a combination of art and science, really, and there is no one one solution to this.
Understood. And do you all end up using distributed training in any way, given the huge volumes of data? And what do you use for that? Like, and how have you orchestrated the infrastructure for that?
Honestly, this is probably a question for my engineers, but I do know that we use distributed training, but I won't be able to exactly give you the full details of that.
Makes sense. No worries. So let's go into the side of the inferencing a little bit as well, Mon. And you mentioned the use of Triton. Was there a particular reason that led you to using Triton, and versus say using a normal model server like a PyTorch server or something? Want to understand like the need for it, and what benefits have you seen there?
Yeah, I mean, Triton was just way, with the kind of load we had. It was just much more easy to wrap that up accordingly. I think, and to scale it up, really. So really, for the scaling purpose, it just made a lot more sense. We For anything traditional. Most of the others were obviously around the PyTorch framework as well before, but at a scale of something where the end of the model is around like a 130B model, it's of a very different scale. And it yeah at that point, you kind of switch to something that can handle that scale.
Understood. And did you get a chance to experiment with something like the TGI, the Hugging Face TGI, or the VLLM model server by chance?
No, I think when we were doing it, they were still on the early days, and we were pushing for our feature to go beta. So yeah, so it's a lot more. Like I said, from the time we did it till now, the market is fundamentally quite different.
Yes. Understood. One question with regards to the dynamic batching part, when you are kind of getting huge volume requests, like what is the strategy that you have seen working for the dynamic batching? Like how should people think of the batch sizes? How should people think of the again the architecture to support it? Would love to maybe know a little bit about what has been your experience there.
I mean, the dynamic batching, at the end, it again comes back to your use cases, the load, your query level, how much volume it is, really going, and being able to just really optimize on and based on how many GPUs you can actually have as well, right? Like, so if you can manage to have 500 GPUs for a 7B model, it's a very different game. Uh,
Yes.
so so it's, at the end, it's all about then what is the final cost that you're ready to sort of put forward for this infrastructure, for this sort of product, and then you kind of actually reverse engineer it to really get a better sense of, okay, with this GPU, how do you actually set everything else up? And that gives you a rough understanding of, okay, this is your queries that you need to batch, and what would that look like for this sort of GPUs of this many clusters with this a layer of load balancing as well as into it. So after a while, and then when none of that works, then you go into model quantization.
Understood. And do you kind of did you also experiment with like low rank or low rank adaptation mode for in your fine tuning as well, or were you like mostly fine tuning the entire models? And what was your experience between fine tuning?
Yeah, so I think we experienced both. There were areas where we needed to fine tune the whole model.
Okay.
And there were areas where literally few layers. And in the beginning, it was trial and error. I remember we fine tuned a model for a certain language, and I forgot the other language it was good at. So we've had that experience as well, and then we had to figure out what is the layers that we want to actually tune to optimize for its use case. So depending on the nature of the model, it really depends on how much of it that you want to fine tune all of it, and that's why getting a better sense of the base model is actually really important. Is what is really there in that base model that you would need to actually complement for specific to your use case, and then knowing the construct of the base model. So a pathway model is quite different to just a simple decoder encoder model as well. So knowing those differences and then knowing how to actually curate with your data is key.
Understood. Awesome. The other question was with regards to the ensemble of GPUs that you mentioned, right? Like, suppose you have GPUs of different kinds, and not everyone being high performant GPUs, some being low. How have you internally kind of designed an architecture to be able to ensemble them in the right manner to be able to handle this request? Is there some nuances, some architectural things you have done to be able to manage them better? Like, basically, how have you kind of optimized the load balancing there? Some
Load balancing or GPUs?
both, like for GPUs first, like the ensemble, and then how are you kind of doing the load balancing with traffic coming in? Yeah.
Yeah, so I think for the low GPUs one, yeah, it was really getting a better sense of our traffic. Our customers are all across. So, but as soon as Europe wakes up, it's very high traffic, and then when US wakes up, it's really high traffic. So, really being able to take the max into the high GPUs around that time, and then for very shorter requests as well, smaller requests, really optimize for even from an ultra to then just a high GPU as well, and then some of it would even be the like CPU as well. So really putting that as a dynamic orchestration between it. But the first part is really being able to test it. So it is like a A/B testing where you actually really play the dance of production, understand where and how, and then based on the quality and latency as well on on your context and things like that, and then being able to actually map that accordingly.
Okay. Understood. And uh, do you also end up using anything like, given the high volume of requests that comes in, something like an async deployment for your models to be able to serve streams or queues of requests, or is that something that you all have not tried yet? Like,
We did it at that time because we've actually moved away from our self-hosted to third-party LLMs. So we have tried streaming as well, and I think we are looking into streamings for our third parties as well.
Okay, understood. We'll love to deep dive into the evaluation side. Like you all have been working a lot on the evaluation. Maybe if you can present a picture of what all challenges you have faced there. What are some of the major problem statements you are working on? What is the research kind of that's going on, and how are you doing it? That will be really good for people to
Yeah.
kind of.
So as far as we have several use cases for within our GitLab Duo suite that goes from chat to code suggestion to explaining vulnerability in your scanning tools. And all of them have different sort of needs and different sort of mechanisms and different set of models as well. Mostly third-party models. And the main part of evaluation is it's truly difficult to really understand on a certain query level which model will work better at and why and at what time, what prompt engineering, static, dynamic, or retrieval will actually make sense for every query in production. And how do you actually balance that, and what is a good proxy of quality and acceptance rate in production. So and to do that, we have several ways. We for the first part is really actually getting a good set of data, which is proxy to your production traffic. So really being able to curate a good data set, which we call prompt library for every use case. And then being able to actually understand from a historic data set what it means to for a code completion, really being able to dissect a data set into a human computer interaction data set, and then assess it accordingly into areas where you think a certain model would perform or not, and what kind of transformation would actually work in most of it. Yeah. We've seen that there is, a lot of people we talk to still do manual evaluation or just human labeling with binary answers, and they all have their limitations yet.
Yeah.
And the idea is to do it in a way that it can be scaled and have a much more data driven, taking away the human noise and the judgment.
Understood. And I know that, like, GitLab has a lot of open source libraries and other components. Do you all plan to kind of release some of the work that you all are doing around evaluation, say potentially for other audience to use? And
Yes, absolutely. I think this is very much still under open source spot. So it is. We are looking to also obviously publish papers in this area as part of the metrics we've come to look into the algorithm. And yeah, so that is in the radar to actually share with the community as much as we can. Yes.
okay, awesome. Is there any good resource that you'd like to direct already based on already the work you have done around evaluation that is out there that people could probably reference or go to? Like anything
Yeah,
that's
so if we are under our group direction AI model validation and and looking into the prompt library, that itself should give people enough indication as to the direction we are taking.
okay, awesome. That's exciting to hear, man. I know, like, we covered different aspects of the LLM, and you had earlier presented this in an one of the LLMs in prod conference, probably the overall LLM architecture. Maybe why don't we take the last 5-10 minutes for you to kind of sum that up for the audience as to what the overall LLM architecture looks like and give that picture at a wholesome view. Is that something that's possible?
It talks about really how you take data and use that to train a open source LLM with third-party LLMs all put together. It goes from actually taking the full data, pre-processing, versioning, tokenizing it, then sampling, shortening, into then your GPU suites for experimentation, training the data, and then into then a evaluation suite of evaluating, comparing, and having a storage for the model checkpoints, your data, the prompt library checkpoints, and model registry, which then finally is part of the link to the deployment engine that has, for our case, it was Triton, inference, fast transformer, a validation of your prompt, which is wrapped around a load balancing to connecting to the front end. So overall, yes, it is kind of a lot of different various complicated pieces, but to be able to look into the native LLMs versus any third party, and to put together having all of these well orchestrated is probably the key.
Awesome. It'll be great if you can share that architecture with me later on. We'll love to put that in the blog when we kind of publish this. Uh,
Absolutely.
Yeah. And Mon, like just to wrap up the conversation, I'd love to hear from you. What are your thoughts on this space in general with the LLMs? New things coming around every single day. Where do you think this space will go to, and how will it impact GitLab's journey? And what are some of the other areas you will invest in, and you will expect other organizations to invest in if they want to be staying ahead of the curve?
Yeah, I think this is just a starting of a very exciting journey. And it's not going to end in LLMs. It's almost the starting point of making AI more applicable. I do think there's still an area of how the infrastructure that supports to make AI applicable is really important. And there is just way too many tools and way too many ways to do it. So really being able to understand the use case, choose an architecture that is forever flexible, so you can kind of iterate on it, is also important. And then really being able to be flexible, especially in around ensembling, because every model is different and there is a new model uh, literally
Coming up.
every week, really. So so really being able to having flexible, compiled, easy, lean architectures are important to take it to the next level. The other part is probably just as human beings, I think this is there's a lot to learn, but there's also learning fatigue as we go in this. So really being able to actually still keep that balance of learning enough, but not feeling FOMO and feeling like you're missing out, because a lot will get consolidated as we go and newer things will come. And this is just a starting.
Where you can interact and probably integrate with other systems is becoming important. Around infrastructure related problems that are starting to show up, with dynamic batching being needed, model warm up times need to be optimized, GPU scheduling needs to be done properly, the right optimization between cost and latency that you mentioned, and all of this will start becoming even more significant as we progress. So it's so what do you hit, like it's literally hitting the bullseye. So thanks for bringing that perspective. It was a pleasure talking to you. Thank you so much. Uh,
Thank you.